Factoring the differences of two squares. So we are still factoring. We have talked about the greatest common factor and factoring by grouping. Let's go ahead and factor something special. So if I'm having a square right here, and I would say this side length is A, then the overall area right here that I have would be, well, how much is this? It is this side length multiplied with this side length. So that would give me an area of A squared. Now, if I would go in there, think about it, it could be a piece of paper, and I'm cutting out a small little corner, like this. And this is also a square. This is B squared. That means it has the side length B, this side length is B, and this side length is B. And that makes this side length also B. So I'm taking this away from my big square. The question is, what is this going to be equal to? How can I write this? So if I'm just looking and focus on my square right here, then I can do this. If I pretend I actually have a piece of paper in my hand, then I could cut this right here in this form. And I would have now, well, how many pieces would I have? This corner down here is gone. All right, this corner down here, whoops, is gone. I cut this out. So if I'm now looking at these lengths right here, then let's have a look what we got. Let's write this in red. Let me first erase this. So for this area right here, how much is that? Well, it is this side length, which is still A, multiplied by this side length here on the side. And how much is this? Well, it is the long side of the long square minus the length of B minus this one. So in other words, it is A minus B long. And that makes now this area this times this. So it is A times A minus B. All right, now let's have a look at the second piece down here. How much is this going to be? Well, it's going to be this side length right here, which is the same as this side length, which was B, multiplied by this side length down there, which is again the long side, everything minus B. So this side length is A, the long side, minus this short end right here. So this is A minus B long. And that makes this, I'm adding to this now. How much was the second one? That was B times A minus B. All right. So what do I notice? I see that on the right side right here, there is a factor of A minus B. And this is the same thing that we have done before. I can factor this out. This would be A minus B multiplied by, well, this plus this. And this can be written the other way around as well. A plus B times A minus B. And I have a factorization for the difference of two squares. So if I write this down in big, A squared minus B squared, something squared minus something else squared, will be A plus B times A minus B. I have the difference of something, and I turn it into the product of two things. Before we actually do this, let's just one more time so that the process is going to be clear. Let's multiply something out. Let's multiply 2x minus 3 with 2x plus 3. I can use my foiling method. That means the product of the first, these two, that would be 2x times 2x. The product of the outer, what do I get here? That would be 2x times 3. The product of the inner would be plus a negative 3 times 2x. And the product of the last, that would be plus a negative 3 times a positive 3. So what I get right here is this. 2x times 2x is the same thing as 2x squared. What do I get when I multiply 2x plus times 3? That would be positive 6x. Plus negative 3 times 2x, that would be plus negative 6x, which is just negative 6x. Plus negative, this negative sign here, I can pull this out and make, in other words, this would be the same thing. So I have minus 3 times 3. And I see in the middle, these two terms are going to cancel out. And what I have is 2x squared minus 3 squared. And if I multiply this out, I get 4x squared minus 9. We are going to follow the exact steps backwards now with the next example when we are not multiplying, but when we are factoring. All right. We want to factor these differences of two squares. The first step will always be write a set of parentheses with squares and ask yourself, what will I need to put in here so that the result is going to be x squared? Well, that's going to be easy. There's just an x. What do I have to put in here so that if I go backwards, the result would be 25? Well, that's going to be just 5. And what I have now is the difference of two squares, and all I need to do now is write down the product. This will be x plus 5 times x minus 5. And if I want to check this by multiplying it back out again, I will get x squared minus 25. Let's do the next example right here that looks a slight little bit more complicated. But I'm really following the exact same steps. I place parentheses with squares, and I'm asking myself what needs to go in here and in here. So if I go backwards, I will get 9x squared and 4y squared. So what will I have to put in here? Well, for the first one, I get 9x squared if I place 3x on the inside of the parentheses. I will get 4y squared if I place 2y in here. Now this right here is your a, this right here is your b, and now I really just have to write this out. A plus b times a minus b. 3x a plus b 2y times 3x a minus b, which is 2y. All right. So let's do one last one with the difference of two squares. 25x to the 4th minus 9y to the 6th. So the question again is, can I do this? Parentheses, squares. Can I place something in here so that the result, if I would go backwards, would be 25x to the 4th? Can I put something in here? If I go backwards, I will get back 9y to the 6th. And I can. So what I have to place inside these parentheses is 5 x squared, because if I now multiply this out, I will get 25x to the fourth back. Remember, when I put equal signs right here, I have to always be able to get back. 9y to the sixth, well, that will be 3. This one here is a tricky one. Y not to the fourth, but to the third. Remember, when I open up the parentheses, the exponents have to be multiplied. So here is A, here is B, and now it's really just a matter of writing it down. A plus B times A minus B. A plus B times A minus B. And what was A and B? 5x squared, 3y cubed, 5x squared, 3y cubed. All right. Let's do one last thing, and that is the sum and differences of two cubes. I could create a similar picture to before, but that would be a little bit more complicated, so we're going to skip this. And I'm just going to write you down the formulas with a little bit of help how to remember this. So a cubed minus b cubed is the same thing as a minus b, I drop the cubes, times a squared plus a times b plus b squared. The second one looks very similar. A cubed plus b cubed is a plus b times a squared minus a times b plus b squared. Think about soap. Well, what does that mean? The same sign as this, the opposite sign as this, and the last one is always positive. And I get soap. This works also for the addition of two cubes. The same sign, always the opposite of this sign, which is negative, and always positive is the last one. So these are two formulas that look very similar at first, but if you just remember soap, then practice this a couple of times, then you will not mix those ones up. All right, let's use those ones, because using these ones, we will do the exact same thing that we have done for the difference of two squares. We want to factor x cubed minus 8. So these are two cubes. I am doing the same thing as before with the simple difference right here. I put parentheses, I put cubes up here, and I carry over the negative. So what do I have to put in the first parentheses? Well, that will be just an x. And in my second set of parentheses, that will be just 2. 2 raised to the third power is 8. Now I see what a and b is equal to, and I just have to put this into my formula. So let's have a look. What do we get? The same sign as before. I just drop the cube. So I get x minus 2. Then I will get the first one squared. This one has to be now the opposite sign of a negative. And what I get is a times b, which is x times 2. The last one is always positive, 2 squared. Now, the only thing that we will always have to do with these kind of problems is this part right here, the second factor, has to be simplified. And if I simplify this, let me now write everything in black, I get x minus 2 times x squared plus 2x plus 4. And that will be it. If you want to practice multiplication of polynomials, I could multiply this back out again to check whether I did this right. Everything multiplied by x, and then everything multiplied by a negative 2. And what you will get when you simplify this, combining like terms and everything, it will leave you just with x cubed minus 8, believe it or not. All right. One last one. 125x cubed minus 27. Look, it is very good to know the list of cubes. 1 cubed, that is 1. 2 cubed, that is 8. 3 cubed, that is 27. 4 cubed, that's 64. 5 cubed, that is 125. These numbers right here are the numbers that will show up in these kind of problems. I see the number 125 and 27, both of which are coming out of this list. These are both perfect cubes. So what I have to do now is I place parentheses minus. So now what I have to put inside my parentheses, well, I have to look. 125x cubed is when I put 5x on the inside of these parentheses. The second one is just 3 cubed. Now 5x is a and b is equal to 3. And now I just place this into my formula. And in my second step, I'm going to simplify the second factor. So that was the same sign, 5x minus 3. The first one squared, the opposite sign, 5x times 3, plus the last one squared. And if I'm multiply the right factor out and simplify everything, what I will get is 5x minus 3 times 25x squared. Be careful right here. Be careful right there. 5x times 3, positive, makes for 15x. 3 squared is 9. That is another one where we have to be careful. Some people write 6. And that is the lesson for today.